So geometric probability, it really is pretty simple idea. A lot of you already know something like this. Okay, for example, imagine a square, and imagine I divided the square into 4 equal pieces. Okay, what is the chance of me if I choose random point in that square? What is the chance of me hitting one of the 1 over 4, 25%, right? That's the idea, basically.
Yep.
That's what geometry probability basically really is. So there are 2 types: one with areas like that, one with the squares. The other one with line segment, something like this. Okay, so Nico, why don't you read this for us?
The
Geometric.
probability problems in this section can be solved by using one of the following 2 principles.
Yeah, one of the principles we already talked about with the area, but let's just review a little bit. So this one is the one with the length. Go ahead.
Suppose a point P of a line
Segment.
AB is picked at random. Then probability that P is on line segment AC equals length of segment AC over length of segment AB.
Right? Does that make sense? Pretty straightforward, right? So if AC is longer than this, you have more chance, right, of hitting AC within this segment, right? Guess what the other one is then? It's going to be for the area. Well, you could actually do it for CV, yeah. But yeah, there are 2 types. One is for like the segment. The other is for the area, the one we just talked about. Hannah, why don't you read this for us? Suppose right here. Hmm?
Because of point P of return as a theta random, and probability that P is in R equals A of R over A.
Yeah, that's the basic idea, and I think most of you already knew this already to start with, right? So basically, all the homework that we're going to be doing tonight is going to come down to either type 1 or type 2. Whether we're talking about in terms of length of line segments or like areas. Okay, that's it. Pretty straightforward. So let's do some examples. Take a look at example 1. Jason, can you read this for us? Yeah, okay, so it sounds sort of difficult. Turns out, so remember I told you it's going to be one of those 2 type 1 or type 2? One with the line segment length and then the other is area. Which one do you think this will fall on? So I told you, type, how many people say 1 right, first length? How many people say area? Okay, it's actually 1. There is no area involved here at all. It turns out, let me give you a hint. It turns out, this picture right here explains this whole situation. The whole thing. I mean, it looks really hard to understand, but this is all you need to really understand this problem. So I want you to all, as a group, think about why this picture represents this whole problem, and you could actually do this really easily. So go ahead, everybody think about this. All right, who could explain to us why this picture represents this whole problem really in a simple way? And some of you ask, are they going to give you these pictures? Of course not. Okay, you have to come up with it. But we're going to discuss, and doing a couple of these, you will understand how to get this sort of diagram. Youngwoo, how does this represent this problem? What is this really saying here?
Every 2 minutes, the bus is there.
Is what?
Every 10 minutes, the bus is there.
Yeah, every 10 minutes the bus is coming, and how long does it wait? 2 minutes. So what are we really looking for? If they want the probability that the bus is there when you go out at random? 2 out of 10. That's all it is. Really, you don't even have to look at everything. You just need to look at this segment right here because it repeats forever, right? Like this. I mean, assuming the bus comes forever. Okay, so all you need is this one. All you need then to figure out is, well, what is the chance of you finding the bus when you get out there at sort of a random moment right here, right? Because everything else repeats right here. You just have to look at this. So it's 2 out of what? 2 out of 10. So look, length of the color segment over the whole segment. You don't even have to look at everything. So it's 2 out of 10, which is 1/5. You should always simplify, right? So you have 1 out of 5 chance, right, that the bus will be there. Does that make sense?
Yeah.
Do you understand what we're trying to do?
Like that.
Yeah, so it's very similar. It's pretty straightforward, okay? Any question? Does this make sense? Okay. By the way, did anybody do 1 out of 12 for this one? Looking at this picture? No one did 1 out of 12? Okay, because some people think that, you know, since the bus waits 2 minutes, you got to add to that 10-minute interval. But yeah, that'll be wrong, right? Because the bus is actually coming every 10 minutes, but within that 10 minutes, you're right. The bus is waiting,
Yeah.
right? So it's not 2 out of 12. It's 2 out of 10. Does that make sense? Do you understand what we're saying? Okay. So that's pretty straightforward. Okay. So let's look at second one then. Here we go. Okay. Somebody read this problem for us. How about How about Hannah over here?
A person who is just beginning archery
Mhm.
lessons misses the target frequently.
Mhm.
And when a beginner hits the target, each spot is as likely to be hit as another. If a beginner shoots an arrow and it hits the target, what is the probability that the arrow hits the red bullseye?
So now, what type is this? Is type 1 or type 2? Type 2 is about area. Basically, what are they asking?
Area.
What is the chance that what? What about the area? Somebody? How about, How about Kaylee?
Like, what's the chance that it'll hit the center of the thing?
Yeah, what's the chance that it'll hit the center of this bullseye? Which has the radius of what? 1. And the whole thing has a radius of? 3. And what do you think they say they're talking about just beginning archery person?
Because
Okay, raise your hand. Yes.
if it was
Professional, yeah. Huh?
the probability that it would hit the red bullseye would be 1.
Yeah, because this is a person who is just beginning the archery lessons, right? If the person hits the target, it's just sort of a random, right? It's not because if you're really skilled, right? You've seen those people at Olympics, right? They like hit right in the middle, right? So that's why this is basically saying it's sort of at random. So what is a random chance that if you were to pick a point in this target, right, you would hit the red section here. So what do we do? This is pretty straightforward. How about Narek? What would you do to figure out this probability? Look at the notes that you did. This is type 2, right? So how do you figure out the probability?
You do 1.
Yeah, what is the sort of the formula? We find the area of the small one over the total area, right? That's what we're doing, correct? Go ahead, everybody do it. See what you get. Okay, I'll wait. Somebody tell me the area of the smaller circle. How about let's see. Julie, what is the area of the smaller circle? Pi? Yeah, because it's pi r squared, the radius is 1. So it's just pi. What is the area of the bigger circle? How about Reagan? Reagan? 9 pi, right? So what happens to pi's? They cancel out. How many people got 1 out of 9 chance?
I did.
Does that make sense? Did anybody come up with 1 out of 3 chance? Because it kind of looks like 1 out of 3, right? Because the radius is 1, the other radius is 3. But you have to actually find the area, right? It's not. Okay, it's just 1 out of 3. It's 1 out of 9 when you look at the area. The pi's cancel out. Okay, so there's 1 out of 9 chance. If you were to pick a point randomly, it would be inside the red area. Pretty straightforward, right? So this is where they get kind of course, interesting. You know your homework problem, they're not going to make it this simple. Yeah, interesting. You know what I mean by interesting. Or they're being creative here. A little bit. All right, so here we go. Joshua, it's not that bad. Joshua, can you read this for us? Oh, sorry, he's absent. Jonathan, can you read this for us?
At a carnival game,
Mhm.
toss a coin on a large table that has been divided into squares 30 mm.
Millimeters. Millimeter is on his side. Hmm?
If the coin comes to rest without touching any line, you win.
Mm-hmm.
Otherwise, you lose your coin.
Mm-hmm.
What are your chances of winning on one toss of a dime?
And they tell you,
Dime has a radius of 9 millimeters.
Mm-hmm. Now, this looks like a good game, right? It looks like you have a good chance of winning. Because look, you have so much. Oh, does this make sense? By the way, what is? Oh, okay. Who can explain to us what's going on here? How do you win? And how do you lose? Can somebody explain? Look at the picture. Okay, Michelle, how do you win this game?
Win by tossing the dime on a space that has no line.
Mm-hmm. So once you toss this, and when do you win?
When your dime hits a line that has no line.
Yeah, when the dime doesn't hit any other line, then you win.
What do you win?
I don't know. Maybe you stuff animal. I don't know. You know. But what happens if it hits the line? Then you lose. You lose that coin that you just tossed, right? The dime. Do you understand the? Okay, now, doesn't this look like it's got good chance of you winning? Look at how much space you have. You have so much. The lines are so thin. Even if right? Yeah, you guys are right. It's just not really good. It's not. It doesn't. You don't have a good chance of winning because because you'll see in a minute why. By the way, how would you then figure out how to actually, get your chance of winning? Well, so I said a little bit creative. What they do is you don't have to look at every single square or the whole thing. You just look at one of them. And this picture, look at this picture. This picture, okay, of course they're not going to give you this picture, but when you really think about it, you just need to think about this picture represents just one square, okay? Of course, this circle represents the dime. And what do you think this shaded region represents? And I want you to think about why they're just focusing on just one single square, which represents one of these small square, and there's a dime, and you see the shaded region. I want you to all think about this. Go ahead, everybody think about it as a group. What does this represent? So let me give you a hint as to why it's a big hint. Look at what you have to really look at. Really, it comes down to looking at the very center of this dime. If the center of the dime lands within this highlighted region, what happens? Do you win or lose? You win. What happens if it's like on the outside, or like if it's outside, if it's on this white part, and you lose? It really comes down to that, doesn't it?
Oh yeah.
Right? Because if the center of the dime lands within this shaded region, of course, not right on it, right? If it's inside of it, right? You win. If it's outside, you lose. It really comes down to this. This whole board really comes down to this. The center of the dime landing within this area. Does that help you? Okay, so go ahead. Well, how are we going to figure out our winning chance? Go ahead, everybody think about this. Okay. What is the chance of us winning? Okay. So what are we basically looking at? By the way, which type is this? Is this type 1 or type 2?
Type 2.
Type 2. You're basically looking at the actual center of this circle. Isn't that right? At that point. So we want that point, which is the center of the circle.
What are the chances of the circle?
Yeah, what are the chances of that center of the circle being inside this shaded region? That's all we're looking at. Isn't that right?
What are the chances of the circle
So
being on
the inside over
No, that's a different question. Okay, so who could tell me? How do we do then? This is type 2. All we need is what? How about, let's see. What do you guys think? Nico, what did your group come up with? What do you think?
We think it's 1 to 144.
Why?
Because if it just has to be the center, then the center is like a point, right?
Yes?
So if you do 1, 2.
No, look at the type 2. Remember the type 2 problem?
Yeah, the area. So
Yeah, so we're looking at which areas?
12 times 12, right?
Right? 12 times 12, which is the area of the small circle, right? Okay. That over what?
Wait, what?
So you're basically looking at, if you were to pick a random point within this square, that's 30 by 30, you want to land inside of this red region. Isn't that what we're looking at? Right? Because if the center of the circle lands within this red region, you win. So how do you find the probability of you picking a point that's inside this red region? What is the chance of you picking a point inside this red region? Area of the small square over the whole square. That's basically what it comes down to. Right? Does that make sense? Okay, guys, listen. Doesn't it really come down to the area of the red square over the whole thing, right? Because if the center of this dime lands within this red region, you win. Right? So you're basically looking at what is the chance of you picking the point that is inside this red region. And what is that? It's the red. It's 12 over 12 over, 12 times 12 over 30 over 30, right? Which comes down to 0.16, right? Isn't that how you find the area of the red region? 12 by 12? What is the area of this whole region? 30 by 30. So this whole thing really comes down to this square. It's this red region over the total region. So is this a good chance of winning? That's only 0.16 is about 16%. It's not really a good chance. Does this make sense? Right? It looks like you got a good, right? It looks like you got lots of space, right? You don't have to just hit this. Hit these. So yeah, you only have 16% chance. Okay. All right. Any question? Does this make sense? All right. Can you do something like this for your homework tonight? Okay. Good.